Hi, boys and girls, and welcome to Chapter 2, Divide Whole Numbers. Let's recall our unit scale. Now, you might have been overwhelmed the first time your teacher showed you this scale and you thought, wow, there's no way I'm going to be able to do all of that information this school year. Well, congratulations. If you made it through Chapter 1, you've done the majority of this scale. Now, let's take this step by step and see all the wonderful things that you've already learned. Recall the correct order of operations when adding, subtracting, and multiplying and dividing. Well, that's the mnemonic that we taught you, PEMDAS. Please excuse my dear Aunt Sally, which stands for parentheses, exponents, multiplication and division, addition and subtraction. Evaluate numerical expressions containing whole numbers and parentheses. Guess what? Evaluate, remember, means to solve. Numerical expressions are the equations without the equal sign. So like 6 times 4 is a numerical expression. Containing whole numbers. When we say whole numbers, we mean numbers that are not fractions and they're not decimals either. And then parentheses. We learned parentheses as part of PEMDAS. The next part of level 1 says use parentheses in numerical expressions containing whole numbers. We've done that too. Find whole number quotients of whole numbers with up to 3-digit dividends and 1-digit divisors using a variety of strategies. Uh-oh, that is not something that we've learned already. So guess what? I'm going to highlight this in pink because this is the part of our learning goal that we'll be doing in Chapter 2. Then we see multiply 5-digit whole numbers by 1-digit whole numbers. We've done that as well. So let's take a look at the other parts of our scale and just highlight the first word of each part because that's what we've done already. We've interpreted numerical expressions. We've written simple expressions. We have evaluated, which again means to solve. We've used parentheses, brackets, or braces. We have multiplied multi-digit whole numbers. But again, what have we not done yet? We have not found whole number quotients of whole numbers with up to 4-digit dividends and 1-digit divisors using a variety of strategies. And pay attention, boys and girls, because this is the key part here. Many times, we just want to find one strategy and just use that. And that's good, but keep in mind that we have to know more than one strategy, and that's what's meant by variety. Let's look at levels 3 and 4. And we're only going to highlight in pink what we're going to be working on in this chapter. Notice that it says we will use strategies, models, and the properties of operations. And finally, we want to be able to sort, especially division problems, into these categories: product unknown, group size unknown, group number unknown, and explain why they're in each category. All right, boys and girls, remember, this is the goal, but it's always good to push higher. Now, in order to do well in this chapter, you might be wondering, well, what do I need to know already? And if you're not sure about some of these skills, it might be good to write down your questions in the questions box of your square so that your teacher knows the areas that you need help in and so that you know which areas you need to do some extra studying without being told. So let's take a look at what we need to be able to do before beginning this chapter. We need to know addition, subtraction, and multiplication. It would be good if you also knew some of the rules of division. It's also important that you know how to estimate. For example, what is 746 rounded to the nearest hundred? Well, 746 rounded to the nearest hundred is 700. And what is 746 rounded to the nearest 10? It is 750. place value. You need to understand the difference between the value of a number and its place value. So back to 746. This place, or the place value of the 4, is tens. But the value of that 4 is 40. We need to be able to interpret numerical expressions, which simply means you need to know when and how to use our mnemonic PEMDAS, which is also known as the order of operations. And you need to be able to evaluate an expression and interpret it like, which part of a numerical expression should I do first, second, third, fourth, and fifth? You also need to know the properties of addition and multiplication. And if you look at your last test and see, wow, I really missed those properties, then that's an area you need to go back to and study, and there are videos available on our channel for you to do that. And finally, you need to remember the 8 mathematical practices. You need to be ready to push through a problem and persevere. You need to be ready to look at someone else's problem and identify what they might have done wrong. You also need to be able to look at your own problems and identify what you might have done wrong. So let's move on. The key vocabulary. You need to know that evaluate means to solve. You need to know these words: dividend, divisor, quotient. You need to know that when someone says to make an estimate, they're also saying to be approximate. So you could say, approximately, how many pencils do you need for the day in 5th grade? You need to know that a whole number, like the number 1 or the number 1,500, is a whole number, but 1 3/4 or 0.75, these are not whole numbers, they are fractions. And then the last thing we need to do is interpret the remainder. What does that mean? It simply means that if I have a remainder of 2, I need to know what that 2 represents. Is it a number of groups? Is it a number of cookies? What exactly does the remainder of 2 mean? Now, these are the strategies you need to be able to use. You remember from our last video, the area, set, and linear models. We're going to review them in just a moment. And then you also need to know the algorithms for partial quotients and estimating. That's what we're going to learn in this chapter. So let's quickly review what each one of these strategies, or what each one of these models looks like. If Ocean created a calendar, you might remember this problem, with 35 spaces to represent days. She drew 5 rows. How many days were in each row? Here you see we created 5 rows, and then we counted 1, 2, 3, 4, 5, and continued on 6, 7, 8, 9, 10 until we got to 35. Once we finished that, we noticed that we had 1, 2, 3, 4, 5, 6, 7 in each row. So how many days were in each row? There were 7 days in each row. Notice I've written the problem 2 different ways. We have to be able to read division horizontally. We also need to read division vertically in this form. And you see the model that we used was an area model, and that model was an array. Let's look at the set model. Owen had 63 snacks in his backpack for 3 classes. If each class has an equal number of students, how many snacks will each class receive? Notice the problem has been solved. There are 21 in the 3 sets. So how many snacks will each class receive? Each class received 21 snacks. And lastly, take a moment and read the linear model, and then we'll look at the answer. You probably noticed the error. The problem says that she ran an equal number of miles daily when it actually should say she ran 2 miles daily. How many days did Marika run last week? Well, she ran a total of 7 days last week. And notice we wrote the problem both horizontally and vertically. So you've seen the area model, a set model, and a linear model. For those of you who feel, you know what, I'm ready with all the prerequisite skills, I know how to use all of the models, and I feel like I'm pretty strong at using division. Well, here's a problem that you can solve. If you're able to solve this problem and properly interpret the remainder, like we mentioned on the last slide, you are probably ready to move on to specific problem solving and then take the test for this chapter. Take a moment, pause the video, and see if you can solve this problem on your own. Okay, you've had some time to solve the problem, and now I'm going to walk you through it. You'll find out at the end if you've gotten it right. We have to use the cubes problem-solving strategy because it helps us focus on the words that are important. So first, I'm going to circle keywords, 113 pencils, Amelia gave her 43 more, and I'm also going to take notes while I'm circling what's important. That helps me understand and process my thinking. Hannah had 113 pencils. Amelia gave her 43 more. That means that I'm adding to the 113. Hannah plans to donate her pencils to children in need. Okay, so that means she's going to give them away. But each child, that's important, will receive the same number of pencils. So the same number of pencils. That's extremely important. And, and the teacher will receive some as well. Okay, so the teacher will receive some as well. How many sets of pencils will Hannah donate? So I need to know how many pencils Hannah will donate. So I'm going to underline the question. How many sets? So I need to know the sets. And it's the children. The sets are the children plus the teacher, because the teacher is going to receive some as well, and each child will receive the same number of pencils. But there's a problem. I don't know how many children there are. I'm looking in the problem, but I have to know how many children there are. Boys and girls, if you notice that error and you said, I'm not able to solve this problem, great job. You are using one of the 8 mathematical practices. Now I'm going to tell you that you have 25 children. There are 25 children. Pause the video and see if you can continue to solve. Okay, if there are 25 children and one teacher, we know there's one because it says the teacher. If there are 25 children and one teacher, that means you need 26 sets. But you probably were also trying to figure out how many pencils each person will receive. If you're doing that, great, you're thinking ahead. So you could have added 113 plus 43, which equals 156. Then you could have divided 156 by 26 and gotten the number 6. But maybe you think a little differently and you thought to yourself, okay, I'm thinking 156 divided by 25 because there are 25 students. If you had done it that way, your answer would have been 5 or 6. 25 goes into 156 6 times, and you would have had a remainder of 6. And you would have needed to know that the remaining 6 would have been for the teacher. If you feel like you understand this problem well, great. You're ready to move on to solving problems that have remainders that have to be interpreted. If you feel, oh my gosh, I have no idea what the teacher just said, that's fine too, because that's what this chapter is all about. Take it a step at a time, learn with a positive attitude, and everything will be great. See ya.